Okay, today our goal is to look at measures of dispersion. The basic idea, last time we looked at the measures of central tendency. So you get a set of data, and last time our goal was to find where's the center, where's the middle of the data. So this time, Malik, can you put your phone away? This time we're going to be looking at how spread out from the center is the data. How much does the data move away from the center? Is it tightly packed in the same spot, or is it spread out? So we're looking at different measures of central tendency. So first up, we are going to do a little bit of an investigation. So we have this data here, and our goal is to try and come up with some kind of a statistic that will measure how far from the middle the data set is. How much does it spread out? So to do this investigation, I'd like you to follow along and open up a spreadsheet like this one. So we got a little Google Sheets spreadsheet here. And we're going to start off by entering in the girls' scores. So if you can make a spreadsheet like this one, and we're going to type in the girls' scores. So 2, 3, 4, 5, 5, 6, 8, 8, 9, 10. So using a spreadsheet like this is useful for us when we're doing our investigations. So when we do our investigations and the skills that we're building here are to help you with your IA next year when we do our IA. So we'll type in the two sets of data that want to be investigated. All right, so first up, what we want to do, let's just format this, and just going to make this, give it a little bit of a box around it. So here on the spreadsheet, you can add a little box, particularly across the bottom and across the top like that. So I'm going to just add a box across the bottom and the top, because in this column here, I'm going to be doing summaries and adding things up. So a little column like that one. So first up, in this cell, I want to find out what is the average of this data. What is the average of this data? So I can use a formula, and I can type in equals. Let me just see, here we can sometimes get auto formats. So up here in these three dots, with this where you can see the summation, we've got some little automatic functions for average. And then if we select the cell range here, it lets us get the average of those ones. And it will calculate it for us here. So the average there is 6. Do the same for the boys' score. Do the same for the boys' score. One way you can do it is if you select from the bottom and drag up, and then click on average, it will go straight to it. So we find the average of these ones. Oops. Let me try that again. So equals average. Okay, so next up, I'm just going to put a couple of lines to separate this out a little bit. I'm going to put lines on the left and right like that. There we go. So what we want here is how far is each data item, how far is each data item from the center? Let me zoom in a little bit, because can you guys, is that a little bit easier for you to follow? Can I pop that away? Yeah. How's that? A little bit clearer. So here, we want to work out how far each item is from the center. So in order to do this, we want the girls' score minus the mean. Let me just put girls minus mean. Like that. Now to make this calculation, I'm going to use a formula. So watch me carefully, don't do it now. Watch me carefully. while we try and do this formula. I'm going to put equals, and I want the girls' score. Now, if I click on cell A2, I get A2. And from that, I want to subtract the mean, which is in A12. Now, don't do anything just yet. I'm just going to show you how this goes wrong. So this is obviously 4 off from the center. And if I copy this one down like this, it's not quite going to work because it's changing the cell A12 each time. Here it's gone to A16. It's offering me a suggestion of always keeping it at A12. So I'm going to say yes to that. So if I look now as I go down, notice how in the formula here at the top, we have a relative cell reference for the column A, where we go 7, 8, 9, 10. But we have an absolute cell reference for the A12 using these dollar symbols, which creates an absolute cell reference. I'm just going to fix my formatting because it's just messed it up big time. Like that. So now do boys minus the mean. Have a go at creating the formula for yourself. Have a go at see if you can successfully create the formula for yourself for both of those two. I shall pause the video and come around and help people as necessary. Okay, so what we're doing here with our calculation is we're looking at each data item. So our first data item is 2, and we're saying how far is 2 from the center? The center is at 6, so it's 4 off. So here on this formula, we're doing 2 minus the center, which will give us minus 4. If we go down to the next one, we're trying to see how far this data item is from the center. So this one is 3, the center is at 6, so it's 3 away from the center. And if we look at this one, for instance, how far is this away from the center? This one, the center is at 6, this one is at 6, so that's no distance from the center. Whereas in these ones, when we look at this one, for example, how far is this from the center? This is 8, the center was at 6, so this is 2 past the center. So this is positive 2. So I'll do the same formula now for the boys. I want to do the boys' score minus the average for the boys, which is here. And then I'm going to copy and paste this one down like that. I'm going to take the suggestion. I'm going to, one more time, fix the formatting. And there we see. This is how far each data item is from the center. Now, what am I after? What am I after today? I'm after a statistical measure of how far everything is from the center. Shall we find an average of this? Shall we find an average? That will give us the average distance from the center. So if I take this one and I find the average of those numbers, look what I get. Look what I get. The average distance from the center is 0. Why? Try and explain to the person next to you why the average distance of all of these data items from the center is 0. So why is the average distance from the center always 0? Well, it becomes from the fundamental understanding of what is the center. What is the center? The center is the exact middle. So let's try and visualize that. So if I just type in the girls' data here, and I do a little bit of a dot plot of it. So the center is at 6 here. This is where the center is. They're evenly distributed either side of the center. The center, if you imagine like a seesaw, balances perfectly the weight of the right-hand side and the left-hand side. That's why it's the center. If it didn't, then the center wouldn't be there. the center would move until it got to a point where it did balance either side. If you imagine two groups of people sitting on either side of a seesaw, if you had three big guys and four little girls on the other side, you could balance the pivot in the middle so that they are evenly balanced on the seesaw, even if there's more data on one side than the other, because the other values will be bigger and they'd be further away. And you can get this fulcrum effect. So the center is always in the center. So when you're looking at the average, if you're looking at the distances from the center and you're trying to find the average distance from the center, all the positive values balance out all the negative values perfectly. So we need to come up with some kind of a way to do this and get rid of that problem. How do we get rid of a minus sign? There's a couple of ways we can get rid of a minus sign. We can just multiply by -1, we can take the absolute function, or we can square it. So what we're going to do is we're going to square it. So if I take the girls and I subtract the mean, and then I square it like this. So I'm just going to take these values this time, and I'm going to square them. So take the values and square them. Do the same with the boys. Just fix my formatting once again. There. So now I've taken all the values and I've squared them. So lastly, what I'll do is I'll find an average of this. So let me find an average of this one, and let me find an average of that one. Let me just check my formulas are all correct. Yeah. Okay. Notice my notation. I don't know if anybody noticed when I wrote in, let me just zoom in here at the top. So when I wrote this in my spreadsheet, being a math nerd, I have to have squared looking properly and all nice. So when it comes to writing your IAs, like with your mini IA, I'll criticize if you're not using the equation editor or you're not using the correct notation. It is essential your notation is always perfect. How do I get the little up to the power of 2? How do I do this? One little trick I'll show you for that type of thing is just go to Google and get the symbol. So the squared symbol. And see if you can see it. Look, so type it in. There you can get the actual character, and you can copy, and then you can paste it in where you want it to happen. So if I paste it in, I get the little square symbol. So if you're trying to get a particular, like let's say for instance, you're going to get the Y hat symbol. If you want this, you can find it on Google, select it, and then copy and paste it in. It's always a technique that you can use if you, because it's not so easy to use the equation editor here in Google Sheets to get it to all work there, but I have managed to maintain my quality there. All right, so what we have here is these are two statistical measures. This is the variance. So let me just fill these ones in. This is the variance, which is a statistical measure of how much the data varies either side of the mean. So which ones are more spread out from the mean? The girls' ones. They're much more spread out from the mean than the boys. Let's see if we can see that visually. Where's my calculator? It's my calculator. I'll go here. Let's put the boys in now. I'll just type the boys in quickly. 4, 5, 5, 6, 6, 6, 1, 2, 3, 4. And then on my spreadsheet, on this here, plot properties. add boys. So if we look, we can see where the center is. The center is at 6 for each. The boys are in orange, the girls are in yellow. I'm sorry, yellow. The girls are in blue, okay? You can see visually how the dots are much more spread out either side of the mean for the girls. Whereas for the boys, even though they have the same center, it's much more scrunched around in the center. And you can see this in these two statistics when we look at the variance. It says that the boys have a very short spread around the center, whereas the girls are much more spread out around the center. This is what we call the variance, and one of the problems with the variance is, in this case, the girl's score doesn't really have a unit. But let's say our data was centimeters. Let's say our data was centimeters, if it was heights. If our data was centimeters, then our average would also be centimeters. If we subtract centimeters from centimeters, we still get centimeters. But here, when we square it, we would get square centimeters. So this statistic, when we find it, has a different unit to the original one. So if we want to standardize that, we can create the standard deviation. And what we do with the standard deviation is we take the variance and we square root it. So the formula for that is we type in an equals, then we type SQRT, square root of that value. And then we can do the same here, equals SQRT of this value. So what we have here is the standard deviation, the average, control. I want just this one. Just going to give this one blue, green. This is the standard deviation. I've got too many decimal points there, so I can control my decimal points here. Just reduce it down to 3 significant figures. Increase this one. There we see the standard deviation. Now, what we did with that one is because we square rooted it, it will have the same units as the original data, which is useful for us. Also, 2.5 is a much better statistical measure of what is the average distance from the center. So if the center is here, 2.5 brings us to about there on the girls. This is about 2.5 away. And if here is the center, then this is about 2.5 away. And you can see that on average, that's how far away they are, isn't it? You can visually see it. There's 2 either side of that value there. And on this one, when I do from here, I go, this one's at the center. So when I do 2.5, there's 3 on one side, 2 on the other. And if you think about a seesaw and how a seesaw works, these 2 being a lot closer have less effect than this one being far away. So what we're looking at here is this is a conceptual understanding for you of what is standard deviation. It measures how far things spread out from the center. It is a measure of spread. This is our main goal for today. So what we're going to look at now is we are going to focus on, so the formula for standard deviation is this. This looks really complicated, but it's not. It's not. So if I just get my highlighter pen, I'll explain the formula a little bit. We don't need to use the formula. I'm going to show you how to do it on your calculator, but I want you to understand the formulas a little bit. So let's start off with X bar. X bar is the mean. X bar is the mean. Xi is each element, each value. So this here is calculating the difference between each value and the mean. So here we're calculating the difference between each value and the mean, and then we square that. That is exactly what we were doing here. So here calculates the difference between each one. Here it squares it. So that cell there is this part of the formula. This bit here adds them all up. So what this bit does is, in the formula, it's when we add up the whole column like this, and we get the variance. And then lastly, what this one does is is because we were finding out the average. So if you add them all up, you have to divide by how many numbers there were. And that turns the sum into an average. So that 1 over n part is simply finding the average. And then lastly, the square root turns it into a standard deviation. So one of the difficult things, if we want to make a question hard, later in the course, we will give you the variance instead of the standard deviation. What you have to remember is the difference between standard deviation and variance is square and square root. So if you need the standard deviation and we give you the variance, you have to square root it. Now, the other bit that we're looking at is the interquartile range. It's a different measure of spread completely. So what we're looking at here is a different type of way of measuring the spread of data. So what this does is it divides the data into 4 quarters and then looks at the difference between the middle two. So here in this dot plot, if we divided the data into 4 quarters, so if this is at the center, then 1 quarter is going to be these two, another quarter is going to be these two, that one's in the center, these ones represent another quarter, and this represents another quarter. So we will find the difference between the middle 2 quarters. How far is that range, more or less like that? We have a very useful diagram that will split the data up into 4 quarters. You might have seen it before. It's called the box plot. So if I just turn these ones into box plots now, like this, it split the data up into 4 quarters. So when I'm looking at the box plots like this one, I can trace the values. So this is the minimum value. I scroll across. This is the lower quartile, 4. This is the median in the middle, 5.5. This is the upper quartile. So the interquartile range is the difference between the upper quartile, which is 8, and the lower quartile, which is 4. So in this set of data, the interquartile range is 4. The maximum is 10. Whereas in this data, the interquartile range is between 5 and 7. So the interquartile range of this one is 2. Let me just pause a second. All right, so let's have a go at the actual techniques using our calculator. We've got 2 data sets here, and we're asked to find the variance, the range, and the interquartile range. I'm going to show you a couple of techniques for this. We'll start by pressing on, and then new, number 1. Just press 1 on your keyboard, and say no to saving it. Add a calculator page always. And then what we're going to need to do is we're going to need to start off by adding a list or spreadsheet. This is a seriously core routine, this one. We're going to add a list here for this one. So our first data is ice cream. So I'm going to call that ice. Next, what we need to do is type in the data. So this data set here, type this data set into your calculator. This one. Okay, should have typed that in. There's a few ways we could do this now. So what the first thing we're going to do is find the variance. That one's trickiest. So what I would ask you to do is press Control and then move to the left. Go back onto your calculator screen. Hopefully you added a calculator screen. I did say always add a calculator screen. Here on the calculator screen, we're going to use a really useful routine, menu 611. We press menu and then just press 6, 1, 1 variable statistics. You've got one list. You're pretty much always going to have one list. I don't know a question you'll ever have anything other than one list. And your list is ice creams. And then we click OK. And it does a whole bunch of calculations and shows us the data here. We saw this the other day. The mean is here. I'm just going to switch mine into 3 significant figures. So to get into 3 significant figures, I press Document 72. Document 72 and change from fixed 3 to float 3. Then press Enter again and it will recalculate everything to 3 significant figures. Or not. There we go. Oh, I scrolled up too much. So what we see here is 171 is the mean. The standard deviation on this course is always going to be this one. The standard deviation on this course on IB AISL is always going to be this one. It's the population standard deviation. We don't use the other one. So our standard deviation is 30.8. It doesn't give us the variance. How could we find the variance? Bon. By squaring it. Now if we want to get the exact value, watch here. If we click the variable button now, notice, look at all this stat dot. So all of the data that we just calculated are individually accessible here in this list. So the maximum is the max, the median is the median, minimum, n is the number of items, Q1 is the lower quartile, the upper quartile. We want to find the standard deviation, which is that one, sigma, that's lowercase sigma, sigma x. So select this, that's the standard deviation, and then square it. And press Enter. So it's asking it for the value to 2 decimal places. How will we do that? Well, let's press Document 72 again. Oops, wrong one. Document 72. To get 2 decimal places, I have to switch to fix 2. Press Enter again. 950.98 is the variance to 2 decimal places. 950.98 is the variance to 2 decimal places. How do we calculate the range? The range is another measure of spread. It talks about how far, literally it is the largest value from the smallest value to the largest value. So we can calculate the range by finding the largest value there and subtracting the smallest value there. The maximum x value and the minimum x value. This will give us the range, 92. For the interquartile range, it's the difference between the upper and lower quartile. So again, we just find the upper quartile, which is Q3, and find the lower quartile, which is Q1. This will give us the range. If we wish to visualize the quartiles, and the minimum max, the range and the interquartile range, we do it by pressing Control. Sorry, let me just pause a second. Are we all following along? Are we ready? A few more complicated steps. Are we ready, Camille? Press Control, Add Page, add a Data and Statistics page. Follow me along carefully. This one's trickier. Click on the X scale at the bottom and put in our ice creams. We get the dot plot. We sort of see how it looks. Then click Menu plot type, box plot, it will turn it into a box plot. And then for us to visualize the values here, press Menu, Analyze, Trace Graph, Graph Trace. Menu 4A, Trace Graph. And then with your left and right, you can click here and you can scroll through the different values so you get to see them. We have minimum value, lower quartile, median, upper quartile, maximum value. And you can see how this data is spread now. You can see how it's spread backwards and forwards. It's very much skewed, this particular set of data, because we have those three extreme values here. We have these three extreme values in the data set, causing quite a distorted looking box plot and spread. All right, so that's how we do it for one variable statistic. If we have a grouped frequency, if we have a frequency table, now, we need to find the mean of that. So let's do it for the second data type now. So I am just going to start with a fresh page. I'm going to press on 1 for new, don't save, always add a calculator. Press Control, add page, and add a list and spreadsheet. We are going to type in our score, and we are going to type in our frequency, FRE. So type in the table of data that we have here. Type in your data. Now, we need to run the one variable statistics again. So go back to your calculator page, press Control and left, move to the calculator page. Menu 611, just press the keyboard button, 611. You use this one a lot. Our X list is scores, but this time we have a frequency list. It's not a discrete list like it was last time, so we don't use one, we use frequency. And it will give us our statistical summary. So we need the variance to 2 decimal places. So we need to take the standard deviation and square it. Let's square the standard deviation. 2 decimal places. Fixed 2. So the variance is 7.85. 7.85 for this. Have a go at calculating the range and interquartile range, if you remember. We press variables, choose the maximum, press variables, subtract the minimum, and then the interquartile range, Q3 minus Q1. Okay. So next up, we want to do a grouped frequency table. So for the group frequency table, I'm just going to go to my spreadsheet here. I'm going to type in a category for weight and frequency. This time I'll have to write something other than FRE. FREQ. Now, remember, if we're doing it from a grouped frequency table, we have to use the mid-interval values. So 2.5, 3.5, 4.5, 5.5, 6.5, 7.5. Use the mid-interval values. And then type your frequencies in.
So why is the first one not 2.5?
Because I typed wrong. 2.5. There. So let's find the three statistical values for this one. We need to press menu 611. We type in our weight, and the frequency was FREQ this time. We can find the variance. We can find the range. Oops. And we can find the interquartile range. All right, I'm going to lead you through the next investigation because it's a little bit trickier. So we'll start off by freshing our calculator. Press on, new, don't save, add a calculator page always. And we are going to need to add a list and spreadsheet page. So we're going to have a go at this investigation here. So start off by typing in the data. We'll call the data X, and we will type in the data here. So 3, 4, 6, 8, 9, 10, 15, 17. All right. I'm going to show you some really nerdy bits and pieces here. Okay? So this is a spreadsheet. We can put formulas into the spreadsheet. Watch me carefully here for this one and then have a go for yourself. Won't take me long. So what I'm going to do is I'm going to press equals there on the left. I'm going to type in the word mean by pressing M-E-A-N. Then I'm going to put a bracket in. And I'm going to add everything from A1. Now, over here, next to the G, up on the top right, you get this little set of bits and pieces. So I want the colon. A1 to A8. There. So that's the mean of all of that data now. That's the mean of the data. So the average for this data set is 9. The average for this data set is 9. I found the colon here. Notice what's red next to the G. Pulls up this little list. I get the colon from there. All right. So what we're going to do in this investigation is we're going to investigate what happens when you add and subtract values. What happens to the data? So I've calculated that. I also need to calculate the standard deviation. So let's see if we can find a formula for standard deviation. I don't know it. Oops. No, I don't know standard deviation. Oh, I forgot to research this. So let me see if I can find it quickly in the catalog. Let me look. Let me just see what the formula is for standard deviation. Oops. Angle number, oops. Sorry, let me pause the video while I find the answer here. All right, so we want to calculate here this time to get the standard deviation equals ST dev, nope, BOP of A1 to A8. There's our standard deviation. So what we're going to do for this investigation, so we've done the first part where we take the data, we find the mean and standard deviation. We're going to add 3 to the values. To every value, we're going to add 3. So I'm going to add 3 like this. I'm going to take equals A1 plus 3. So I've added 3 to the value. What I can then do is I can copy and paste this into my cells. So I can press, there's 2 ways to copy and paste. You can press and hold on this button here and then pull down like that until you get to the one that we want. We have 8 data items. And then press enter, and it will copy and paste that first cell, which is that first cell, which is A1 plus 3, and it will add 3 to all of our items. We can.
For the standard deviation, we got like 86 over. It's giving me like the square root of 86 divided by 2. How do we like simplify? Is there something that says that?
I see. So if you don't get the standard deviation here as a decimal, you can force it if it's giving you exact values by changing your document settings, documents here, and in the calculation mode, require approximate and switch off exact arithmetic. Something on those lines will stop you getting square root whatever in your values. I'm just going to change my to float 3. All right, so we want to copy and paste these formulas across. Another way to copy and paste is to press Control C and Control V. So we copy and paste that one across. We can copy and paste this one across. Control C. Go here and press Control V. So what has happened? When we've added 3 to each data item, how has the average changed, the mean? When we've added 3 to every data item in the list, how has the mean changed? What was the mean before? What was the mean before?
It increased by 3.
It increased by 3. So when we've moved it across, it's increasing by 3. What about the standard deviation? That hasn't changed. When we've moved it, that hasn't changed. Why? When we add 3 to all of the data items, the mean will move across, but the standard deviation won't change. And I can visualize this for you again with the box plots. So this idea here is, let me just go back a page. These ones is x plus 3. Oh, it's not going to let me do that. X plus 3. Oh, it's not letting me. Let me just call it x3. So here on the list and spreadsheet, I put in my x variable as x, and then on the menu, I choose plot type box plot, and this is how the data looks and how the spread is. So then on the menu, on the properties, I add another x variable, and I add the x3, and we can compare these side by side. Notice how the box plot is the exact same shape. By adding 3 to each data item, we get the same shape, but it just moves all the data across on the x scale, which is why the mean moves across by 3. This is why I can't show the mean here on this one, but I can show the median. If we look at the median here, the median is at 8.5, and on this one it goes up to 11.5. The whole thing goes across by 3. If we subtract 2 from each here, if we subtract 2 from each data item, what's going to happen? Well, let's try that. Let's do x minus 2. Oh, it's not going to let me type that in. I'll call it x2. No. So here on this one, we want to take the original item, which is A1, and we want to subtract 2 from each item. Then I can press and hold here. Click on this one, press and hold here. No. Let me see if it's going to let me do it. Let me copy and paste this way. Paste it in, maybe like this, Control V. Control V. draw. Oh, I wish I'd done this in Google Sheets. It would have been so much quicker. Sorry. Control V. Okay, let's copy these ones across. And as we would expect, what's happening here is the mean is going down by 2, but the standard deviation doesn't change. How does the box plot look? Let me add another plot for this one. Let me add another x variable. There's x minus 2. Yeah, it moves down. It moves down. Let me take that one off for a second because I want to do one more, and let's have a look at what happens when we multiply. So in that particular example, we are taking each value and we are subtracting 2. So looking at this one, I'm going to multiply by 3 and see how it affects the standard deviation. If I multiply by 3, how do you think the box plot will change? Bob? It's going to get bigger. So let's just watch this one now. I'll just do this last one for us. So we've got x, 3. So I'm going to multiply everything by 3. So this one is going to be the first value multiplied by 3. X times 3. Will it let me copy and paste it down? It will not. Come on, let me do the easy copy. Yes. There we go. I've multiplied everything by 3. Let's see what happens to the mean and the standard deviation here on this one. So firstly, the mean is going to now be much bigger. What was the mean of the original data? What was the mean of the original data? 9. When I've multiplied by 3, how has the mean changed? Also multiplied by 3. Let's see how the standard deviation changes. So if I take this value, copy it, paste it in here, it's also 3 times bigger. So when we add 3, the standard deviation doesn't change, but the mean goes up by 3. When we multiply by 3, it becomes 3 times bigger. The data becomes 3 times bigger, the mean becomes 3 times bigger, the standard deviation becomes 3 times bigger. And it would be good for us to look at this and compare them on the box plots. So I'm just going to remove the x row. So there's the original data, and now I'm going to add the multiplied by 3. Notice how the box plot, it has the same sort of shape and distribution, but everything is just exaggerated and stretched 3 times bigger. So in summary on that one, if we add items to a data set, the center will move, but the spread won't change. If we multiply, everything becomes enlarged, the spread and the center. And that's what gets summarized there. So here is a summary of that. So the mean is x bar, the standard deviation is sigma. If you add a value to it, add or subtract, it's going to change the mean by that, but not the standard deviation. If you multiply by k, then the mean will change, and so will the standard deviation. All right, that is it for today. We need to work with exercise 3D for homework for this class. You may go to the bathroom now.